We are going to solve polynomial equations by either factoring or using the quadratic formula. So when I first have a polynomial, the first thing I look at is to see if all of the terms have anything in common. And what you'll notice in this first example is they all have an x. So I'm going to factor that out first. So when I factor x away from x cubed, I'm left with x squared minus, when I factor x away from the minus 28x squared, I'm left with just minus 28x, and plus, when I factor the x away from 27x, I'm left with 27. Okay, so now this has left us with a quadratic here, and so with quadratics, we will try to first factor it, and then if it doesn't factor, we will have to use the quadratic formula. Now, don't forget your x term that you also factored out there. When we are looking at trying to factor this, we're going to focus on our constant in this case, and first we'll break apart our x squared as x times x, and when we're focusing on our constant, we're trying to think if there are two numbers that multiply to give me positive 27, but when I add them, they would be negative 28. And so in this case, if we were to take a negative 27 and we were to multiply it by negative 1, the product is positive 27, but when you do your outside inside and you add those terms up, you would get the negative 28x in the middle. So that particular quadratic does factor. Now, once you have reached this stage where everything is in a factored form, you set each individual factor equal to 0 and you solve it. So x by itself is a factor. We set it equal to 0. There's nothing to solve. That is one of my solutions. X minus 27 is a factor. We set it equal to 0. We're going to solve for x. So we're adding 27 on both sides. So x equals 27 is a second solution. And then finally we had the factor x minus 1. We set it equal to 0. We're going to add 1 to both sides. So in this case we get a third solution where x is equal to 1. So we had x equals 0, x equal 27, and x equal 1. Now, on this second example, you'll notice that if I tried to factor it, I can break apart the x squared as x times x. And if I'm focused on the positive 12, and I'm thinking of factors of positive 12, I know both positive 1 and positive 12 or negative 1 and negative 12. Okay, then I could also look at positive 2 and positive 6. That gives me 12, or negative 2 and negative 6. And in none of these cases so far have they added up to negative 6. So I'm going to keep going. I could say factors of 12 would be positive 3 and positive 4, or negative 3 and negative 4. And again, neither of those add up to that middle term. So when this happens, you have no choice but to use the quadratic formula. And so first thing is you've got to know the quadratic formula. So x equal, we're going to say the opposite of b, plus or minus the square root, and then under that square root you have a b squared minus 4 times a times c, and then that whole thing is divided by 2 times a. Now, the a, the b, and the c are going to come from your coefficients. So a is always your coefficient of your squared term, b is always your coefficient of your x term, and c is always your constant. So when I go to solve this particular quadratic using my quadratic formula, notice in this case my b value is a negative 6. Because the formula says take the opposite of that, I'm going to have the opposite of negative 6, so that will turn into a positive 6 when I go back and simplify it. Then I have plus or minus the square root, and then under the square root I'm going to take my b, which was negative 6, and square it, minus 4 times, when I look at my a value, I don't see anything there, so that's understood to be a 1, times when I look at my c value, it is a positive 12. And then that whole thing is going to be divided by 2 times my a value, which was 1. So now I'm ready to come back and simplify. A opposite of negative 6 would be a positive 6, plus or minus the square root. Negative 6 squared gives me 36, minus when I multiply 4 times 1 is 4, times 12 would be 48, all divided by 2 times 1 is 2. So I'm going to keep going. 6 plus or minus. When I take 36 and I subtract 48, I'm left with negative 12. All of that's divided by 2. Now, we've talked in the past that we cannot take square roots of negative numbers, and that's what we have here. We say that they're not real. In this case, because they're asking us to identify all solutions, that means they also want us to identify the ones that are not real. So we are going to keep going in terms of simplifying. And what I'm going to do next is break down that negative 12 into some factors. So I'm going to pull the factor of negative 1 by itself. And we'll talk about the square root of negative 1 in just a minute. And then the 12, when I think about the largest perfect square factor of 12, that would be a 4. And I'm going to do that so that I can simplify that number under the radical. And then, of course, I still have the 2 on bottom. So as I keep going, I've got my 6 plus or minus. Okay, so let's do the easier part first. The square root of the 4 is going to give me a 2 that's outside of the radical. Now, by definition, you need to know that your square root of negative 1 is defined as I, the imaginary number I. So when I say the square root of that negative 1, that gives me an I right there. Now, we cannot take the square root of 3, so that gets left underneath, and then we have a 2 that is on the bottom. So for this last step, you're going to look to reduce if possible, but you have to be very careful because this 2 on the bottom applies to both of those terms on the top. So you can't just divide it into one of the terms, you've got to actually divide it into both. So the 2 on the bottom will go into 6 3 times, and then I have plus or minus, and then the 2 on the bottom goes into that 2 once, so you're left with your I and your square root of 3. And you can see that this is how they wrote the answers here with the, just make sure if you're going to type it in, the I is not under the square root. Or what I would suggest is that you actually put the I out in front. So when you're typing it in these boxes, I would probably go 3 plus and then put my I square root of 3. And then I would go 3 minus and then put my I there just to make sure you don't get it underneath that radical.